Hey there. Yes, you. If you're watching this video, chances are you're just as curious as I am about virtual agents. And maybe, just maybe, you've had a crazy idea to build your own agentic system. Sounds exciting, right? We all know how powerful agents can be in solving complex problems. But have you ever considered the risks these systems face in the real world? Attacks that could extract sensitive data or even gain unauthorized access? Think about examples like data leaks or system breaches. Scary stuff, right? Since no system is perfect and unpredictability is part of the game, how do we test these systems effectively? How do we analyze their behavior and improve test coverage? In this tutorial, I'll show you how to create a system of agents to do just that. This system will explore your graph node by node, simulate critical scenarios, run tests, and provide actionable feedback on where your system thrives and where it needs improvement. Ready to dive in? Let's get started. All right, let's jump right into it. Before getting started, the system needs three things. First, a LangGraph system before it's compiled. Second, a brief description of the system. And lastly, an input that can be processed by this graph. In code, these three elements can be represented like this. The first step, traversing the graph, node by node, to pull out all the information it contains. We can store this information using a graph database like NetworkX in Python. Here's how it's done. A for loop through the graph to extract each node's information, including even the tools functions associated with it. Once we have all that mapped out, the next step is to execute the graph using the input which the users provided. This lets us gather input and output data for each node, which will be crucial for creating test cases. Once we have everything collected, we're ready to move on. Next up is stage 2, where things get really interesting. We create multiple agents, each taking on the role of a tester. These agents propose test cases using the information we gathered earlier. Each test case has a name, a description, acceptance criteria, and the tester ID to identify who created it. Here's the exciting part. With LangGraph's parallel processing power, we can create a separate thread for each test case, generate a new input, and then execute it. Later, it would be easy to identify every execution because they are associated to the tester ID and the test case ID. Finally, in the last stage, after running all those tests, the system analyzes which tests succeeded and which ones didn't, based on the system behavior and acceptance criteria. Once the process is complete, the user will receive a detailed overview of all the test case results, including any relevant comments and insights. This way, the system can autonomously explore a graph, identify vulnerabilities, and flag areas that need improvement. I hope this gives you a solid overview of how the system works. If you want to dive deeper, I've linked a detailed notebook in the description. It contains all the code and a step-by-step explanation of each part. Let's keep exploring.